This is Mrs. O'Neill for Chapter 10, Section 2, Part 2, Mole-Volume Relationship. So this is back to our mole roadmap, or in your notes, I like to call it Mole Island, but it's very similar. Again, this time I put those alligators in there just to make sure you're understanding that we need to go from mass to moles or moles to mass. We cannot go from mass to volume and back to mass because those little alligators or big alligators will eat us alive, right? So we have to think about these as bridges. And this time, this video, we're going to be looking at that mole to volume bridge and the volume to mole bridge. Again, we have those conversion factors, but depending on which way we are going, depending on which way we are converting, we're going to use that conversion factor two different ways. But let me remind you, notice the 1 is always with the mole. And notice that this time, no matter what substance we're dealing with, as long as it's a gas at STP, we will be using the number 22.4. So Avogadro came up with this hypothesis, and it's still a hypothesis, it's not a law yet, that states equal volumes of gases at the same temperature and pressure, and again, the same temperature and pressure, they're really referring to the temperature and pressure at STP, equals the same number of particles, and which is this Avogadro's number. So let's look at these two boxes. The volume occupied by the gas molecules is equal to the number of particles regardless of size is going to be this Avogadro's number. So in instance, the molecules in this container are rather small, right? Smaller than this container, but it's small. But if we have 22.4 liters, we're going to have Avogadro's number of particles. So if we're looking at this container as a comparison, the larger molecules in here are going to have the same number of molecules, again, as long as we have 22.4 liters. So no matter what the size of the particle, we're going to always have Avogadro's number of particles if we're dealing with a gas and we're dealing with STP and we're dealing with that 22.4 liters. So this makes converting really, really easy between volumes of gas and particles of gas and moles of gas. So pause the video, fill in those blanks, and then play to hear my words. So we've talked about STP a couple of times now, standard temperature and pressure. So these are the conditions at which the volume of a gas is measured. 0 degrees Celsius, and for pressure, it's 101.3 kPa, which is an abbreviation for kilopascals, and 1 atm is an abbreviation for atmospheres. So for our purposes for this particular chapter, you just need to understand that STP means standard temperature and pressure. Standard temperature is 0 degrees Celsius, and standard pressure are these two values with those two different units for now. But really what it truly means is these are the conditions at which a volume of gas is measured under these standard conditions to give us that 22.4 liters. So let's look at example 1. In this case, I didn't actually have you get out your periodic table because it's really not necessary. We're never going to need the mass of our substance because we're dealing with liters and moles. However, you might want to have out your calculator. So pause the video, make sure you have a calculator and ready to rock with your brain cells. So what is the volume in liters of 0.0032 moles of carbon dioxide at STP? Well, what do I want? I want volume. Where am I going to go? Or where am I going to start, I should say, at moles, right? So again, I want volume. I look at my number, and the unit next to the number is going to be my starting point. So again, I really don't need the periodic table because it tells me what substance I'm dealing with, but I don't need to look up its mass. So how am I going to start the problem? Again, we're going to start with the number of moles. We're going to multiply by a conversion line. No matter what, moles is going to go on the bottom because I want to cancel out that unit, and liters is going to go on top. Remember, with these mole conversions, the 1 always goes with mole. And now for liters, it's always going to be 22.4. Now go back to that, if we're starting with moles, we're going to multiply. Well, this makes sense. I'm starting with moles and I'm multiplying by my value. So that should make sense. I'm pretty sure I made the conversion set up correctly. All right, so pause, plug and chug into your calculator and make sure you get the right answer. Hopefully you took the time to do that and you got the answer of 0.0717. Again, I usually go to 2 decimal places, so 0.072 would be fine. Again, that's not really 2 decimal places, but I always like to see at least 2 numbers other than zeros. I guess I should say it that way, either 2 decimal places or 2 numbers after the decimal point. Okay, and so again, and I included the substance CO2, the molecule of carbon dioxide, but it's not necessary. All right, number 2. What is the volume? Again, I'm looking for volume. That's going to be my question mark, of 730.2 moles of nitrogen at STP. Now, in this case, I'm going to assume, because I'm dealing with gas, it's going to be the diatomic molecule of nitrogen with its formula N2. But that's actually not really necessary. Knowing the formula for these problems is not necessarily, because I don't need to know the mass. So again, I want volume. I'm looking at my number and my unit next to my number is moles. So that's going to be my starting point. So let's start setting up the problem. I'm starting out with that many moles times my line. Moles goes on the bottom, liters on top. The 1 always goes with the mole. And in this case, I'm using 22.4 again, because I'm dealing with moles and liters. Again, it should make sense because I'm starting with moles, I'm going to be multiplying. So pause the video and push and chug into your calculator. Hopefully you got that as an answer. And depending on your calculator, it either gave you long form of the number or scientific notation. Remember, these 2 numbers equal each other. All right, off to example number 3. How many moles is in 1.25 liters of He, which would be helium, at STP? Again, helium's a gas. So it says how many moles, that's my question mark, that's where I want to go. And then I see a number here with a unit after it. That's going to be my starting point. So I have a starting point of 1.25 liters times my line. This time liters goes on the bottom because I want to cancel out that unit, and moles goes on top. Again, what number goes with moles no matter what? 1. And in this case, 22.4 goes with liters. So I'm starting at a different unit going to moles, so I will be dividing those 2 numbers. Aha. And again, you might want to do it in order. 1.25 divided by 1 times 1 divided by 22.4, just so you don't do it the other way around, right? If you did 22.4 divided by 125, you're going to get a totally different answer, okay? So do it in order. All right, pause the video and push into your calculator, and you should have gotten that as an answer. Again, if there's zeros, I like to always have 2 or 3 numbers associated with it. All right, example number 4. At STP, we have this many liters of neon, and neon's a gas, would contain how many moles? So again, our question mark goes with moles. That's what I want as an answer. Here's my number and my unit of liters. So that's going to be my starting point. All right, let's set up the problem, starting with our number and unit that they gave us times a line. Liters goes on the bottom because I need to cancel out that unit. Moles goes on top. Ding, ding, ding. Where does the 1 go? Goes with the mole. And since we're dealing with liters and moles, I'm going to use that magic number of 22.4. Again, pause the video and put this into your calculator. Remember to use that magic EE button. Hopefully you got that as an answer. Again, the number of moles, and I put the substance of helium. All right, so hopefully that makes sense. Again, I try to do things step by step so you're seeing the process, and it's the process, the same process every time. So here are our practice problems. And if you notice, again, I gave you the same substances all 3 times, or I should say for your A's, your B's, and your C's. But again, just as a reminder, since we're dealing with moles and liters, it doesn't really matter what the substance is as long as it's a gas, which you're going to assume it is, whether you know it is or not, because they're telling you it's at STP and it's telling you they're gases. But we really don't need the periodic table. We do not need to know the masses. So pause, set up the problems. You have room in your notes to do that, and then check your answers by playing the rest of the video. Hopefully at this point you paused, you set up the problems. Hopefully you did at least number 1 and you got these answers. So pause and make sure that your setup is correct as well as your answers. And if not, hopefully you've made some notations or questions on the side that you'll either ask me or a classmate in class. And your answers to number 2, again, pause and make sure your answers are correct. All right, a 1-question quiz. So again, pause, read the question, maybe do a little setup or something on scratch paper or in your margin of notes, and get an answer. Hopefully you got this as an answer. All right, guys, we will see you in class.